Hello, and welcome back. We are going to be speaking about how to solve systems by substitution. If we recall, we've already done solving systems by graphing, and so that's when you have y is equals on both equations. And now we're going to tend to experience when we have equations written in a different format, and that'll call for solving them using the substitution method. So what is the substitution method? Really, all it really entails is that we take an expression that we know equals a variable, and we substitute it in for that variable into another equation. So if you had something that says x equals 5, then you can take the 5 and put it in place of x. The same way if you had x equals 5 plus y, you can take the 5 plus y and put it in place for the x. And that's what we're going to do. We're going to be substituting what we know a variable equals and then put it in place of that variable in another equation. So what that process looks like. So we think about when we see an expression, we see a system rather, we think to ourselves, do either of our equations have either x equals or y equals, so like a variable solved for? If not, then we have to make that happen by solving for a variable. And so that means we want to look for an equation that has a leading coefficient of 1, or not leading coefficient, but the coefficient of 1. So like there's 1x and there's 1y. If all the coefficients are not 1 or none of them are 1, we really don't want to use substitution. We use a different process we'll speak to later. But hopefully one of them will have a coefficient of 1. We will then solve for that variable because all it will take is addition or subtraction, no introduction of fractions, which is nice. If one already does have an x equals or y equals, one of the equations, then we can use that equation and then keep on rolling. We will substitute and then solve the remaining variable. And then now we're on step 4, in which case now we have a value or a number to what one of the variables is. We can substitute that value into the previous equations and then solve that remaining variable. And then as always, we check our solution in all of our equations or both of our equations. Again, when we look at the process written out, it seems more daunting, it seems more difficult than what it really is. But that's just how math kind of works. When you write it in words, it's much more difficult looking than when you actually do it. All right, so let's do some to make sure we're all on the same page. So let's look at this example. We want to solve the following system of equations: y is equal to 2x minus 5, 3x plus 4y is equal to negative 9. So when we look at this, do we have, or ask yourself, do we have an equation where it says x equals y equals? Yes, we do. We have y is equal to 2x minus 5. Because we have that, we can take that 2x minus 5 and substitute it in place of the y in the second equation. And so we'll get 3x plus 4 times the quantity of 2x minus 5 equals negative 9. And notice that 2x minus 5 is directly where the y is. We just substituted that right in place of the y because they're supposed to be equal to one another. Now that we have this particular equation, we can then begin to solve it for x because it's the only variable that is there. So when we do that, we would distribute the 3 to the 2x, the 4 to the 2x and the 4 to the minus 5 and get 3x plus 8x minus 20 is equal to negative 9. And then we notice that we have 3x plus 8x, which are like terms, so we can combine those into 11x, and then we have 11x minus 20 is equal to negative 9. Now we notice we don't have any more like terms, and so we want to then move our number term, which is minus 20, to the right-hand side. And so we move that by doing the inverse operation, or adding 20 to both sides of our equation, and that'll give us 11x is equal to 11, because negative 9 plus 20 is 11. Now we recognize we have multiplication, 11 times x, and so to undo multiplication, we need to divide on both sides, and we'll divide by that coefficient of 11, which means x is equal to 1. So now we know what x is. X is 1. And we can take that 1, and we substitute it right back into our equation that tells us what y is. Because y is 2x minus 5, since we know what x is, we can find out easily what y is. So that means you put the 1 where the x is to give us y is equal to 2 times 1 minus 5. And then we just evaluate that. 2 times 1 is 2, so we have y is equal to 2 minus 5. 2 minus 5 is minus 3. Y is equal to negative 3. So now we know what x and y is. Before we say we are finished, we should always check our work. And so we want to make sure that our solution actually is a solution. And what it means is it makes the mathematical sentence true. It gives us a true statement. That's what it means to be a solution. It'll give us a true statement. So let's substitute those numbers in and see if it's true or not. When I put 1 in for x and negative 3 in for y in that second equation, we get 3 times 1 plus 4 times negative 3 is equal to negative 9. And the question is, are these actually true? Does this equal one another? So that gives us 3 minus 12 is equal to negative 9. Maybe. We're trying to find out. Negative 9 equals negative 9. That is true. Yay. It works in that second equation. We should also check it in the first equation because it needs to work in both. Now, the first equation, it should work because we utilized it to get the number negative 3 for our y value. So just by that alone, it's going to work as long as we did all of our arithmetic correctly. But we should check nonetheless. Y is equal to 2x minus 5, so negative 3 is equal to 2 times 1 minus 5. 2 times 4, and the question is, are these equal? 2 times 1 is 2. Negative 3 is equal to 2 minus 5, which is negative 3. Negative 3 equals negative 3. That is correct. So there's our solution. 1, negative 3. All right. Moving right along to our second one. X plus 4y is equal to 2, and 3x minus 7y is equal to 44. So again, we look at our system and we ask ourselves, are any of our equations written as x equals or y equals? No, none of them have that. So then we say, well, is it easy to make one of them x equals or y equals? And this idea about ease is, do any of my variables have a coefficient of 1? And so I look at my variables. In the first equation, you have 1x plus 4y is equals 2. Right there, we already have a 1x. In the second equation, you have 3x minus 7y is equal to 44. But we should choose the one that has a variable, the variable that has a coefficient of 1 rather. And so we're going to use that first equation, and we're going to solve it for x. And to do that, we're going to subtract 4y from both sides, because that'll move that y term away. And that'll give us x equal to 2 minus 4y. And then we can take that expression, which equals x, and substitute it in to find out what y is. Again, when we substitute, we should always use parentheses. And so when I rewrite this, we have 3 times instead of x. We have 2 minus 4y minus 7y is equal to 44. And then we can distribute the 3 to the 2 and the 3 to the minus 4y, and we'll get 6 minus 12y minus 7y is equal to 44. We notice we have like terms in the minus 12y and the minus 7y. So we can combine those, and that'll give us 6 minus 19y is equal to 44. Now we have a two-step. We need to move the 6 away from the same side as the y term. Notice it is a positive 6. Please do not try to add 6 because 6 plus 6 is 12. We want it to go away, and so we need to subtract 6. 6 minus 6 on both sides. 6 minus 6 would be 0. 44 minus 6 would be 38. And that'll give us negative 9y is equal to 38. Then we can divide both sides by negative 19. And that'll give me that coefficient of negative 19. And so y will equal negative 2. Well, now I know what y is. We can take that y, or that value for y, and substitute it in to our equation that tells us what x is supposed to equal. 2 minus 4 times negative 2. Because the negative 2 went in place of the y. And then we can continue to evaluate. Negative 4 times negative 2 is a positive 8. So we have 2 plus 8. 2 plus 8 is 10. X equals 10. Just like before, we should always check. All right, always check. When we check this, the question is, when I substitute the x and the y, do I get the right-hand side of the equation? Do I get this 2? That's the question. Are these actually equal? So again, I just put the 10 where x is and the negative 2 where the y is in the first equation. 10 plus 4 times negative 2 equals 2. I can simplify the left-hand side. We get 10 minus 8 is equal to 2. The question again is, are these actually equal? And then 2 equals 2. Yes, this is correct. I should check in the second equation as well. 3 times 10 minus 7 times negative 2 is equal to 44. Again, substituting in for the x and the y using parentheses. And then we can evaluate that. 3 times 10 is 30, and negative 7 times negative 2 is positive 14. So we have 30 plus 14 is equal to 44. 30 plus 14 is 44. 44 equals 44. Yay. So there's our answer. 10, negative 2. Cool? Great. Now I'd like us to try some on our own. So here's the first one. Solve this system. Go ahead and pause the video and solve this system. All right. Hopefully we're back. So in our process of solving, I just want to spot check a few things. I'm not going to write the entire thing out. So really we're just checking to see if some aspects of our work are similar. Hopefully we recognize that we have y is equal to something, and we can take that something and substitute it into the second equation. And so that'll give us this 4x minus 6 times 2x minus 11 equals 18. If you were stuck on this first step and you didn't get this, please go ahead and write it now and then try to finish it on your own. Go ahead and pause the video to finish. All right, now we had time to look at this. We will then distribute, and so we can solve for x, and that'll give us 4x minus 12x plus 66 equals 18. And when we finish solving, we get x equal -3. If you did not get x equal to -3, please go back and check your work to find out where your error might be. Go ahead and pause the video to check your work. All right. Now that we found out where our mistake might have been and we've gotten x equal -3, we would take the -3 and we would substitute it into the original equation, the one that says y is equal to -2x minus 11. And that'll give us y is equal to -2 minus 3 times -3 rather, minus 11. If we didn't get this part, go ahead and pause your video to make sure you can finish from here. All right, we'll stop there. Or start there, start from here. So when we do this, we end up getting y is equal to -5. Once again, if there is an issue with your either multiplication of -2 and -3, or your combination or combining that result in -11, please go back and check your work. But that is our result, -3, -5. All right. Let us then try another one. Here is a system, 4x plus y is equal to 8, and 5x minus y is equal to 1. Go ahead and pause the video and give this a try. All right, so what I did, and this is not the same thing that you have to do. You don't have to do the exact same way that I did. I recognize that in the first equation, we have a coefficient of 1 on the y. In the second equation, there's a coefficient of -1, but I don't want to divide anything. So I use the first equation by solving the first one for y. And when I do that, you get y is equal to -4x plus 8. If you did not do this, it is fine. You could still end up with the correct answer as long as all the arithmetic and algebra is correct. Okay? From there, I took that value and substituted into the second equation and got 4x minus -4x plus 8 equals 1. It is very important. This is the reason why we use parentheses that we notice our signs. It's 5x minus whatever the y is. And the y happens to have a negative in the front. So 5x minus the y, which is -4x plus 8, equals 1. If you left your negative signs off, it's probably because we left off our parentheses. Make sure when you substitute, you use parentheses. Once we're here, go ahead and pause the video and see if you can finish this out to find out what the x value is going to be. All right. When you work this out, you should get that x is equal to 1. If you got a fraction here, it's probably because you didn't distribute this negative that's in front of this parentheses to that 8. All right, do make sure we're really careful with our distribution. We should get x equal to 1. Now we know x equals to 1. We can take that and substitute it into the 4x plus y is equal to 8, or the y is equal to -4x plus 8 equation. And that'll give us y is equal to -4 times 1 plus 8. Go ahead and pause the video to make sure you can get what y is going to equal from here. All right. At this point, we can then get y is equal to 4. Please make sure you can get this entire situation. If you chose to do something different in the beginning, like you solved the system for the y in the second equation, your work will look different, but your answers will be the same, as long as your arithmetic is correct. Now, if you checked your work like you're supposed to, you'll realize that if you don't have these numbers, 1 and 4, x is 1 and y is 4, then it's not going to work anyway. But that is our solution, the 0.1, the 0.14. All right. Now in class, we'll practice this some more, and we'll do some applications just like we did with our solving graphing. See you later. Bye-bye.